Good morning, Braylon, or afternoon, or whatever time it is over there in your house. Today, I want to talk to you about Lesson 21, and I will also then do a separate video for Lesson 22, and you can watch that, and then you can practice your problems as you watch the video. So watch Lesson 21, and then we'll do some problems together, and then you can do the problems that are assigned for Lesson 21, and then I will send you a video for Lesson 22, and you can practice those problems as well. Your mom can grade them, and then we can go over those together when we meet. So let's go ahead and start with Lesson 21. So there's only a couple concepts here in this lesson that we're going to be talking about, and those are listed here at the top. Lesson 21 is the product rule for exponents and the addition of like terms with exponents. So those are the two things. I like these packets. These are actually packets that Ms. Misha has made up and your mom shared with me to use with you through this summer. So all of the things that we're going to be talking about are color-coded off to the left over here. But I'm going to take some time on a separate sheet of paper to go over some things with you, and then we'll come back and review those rules. So I'm going to go all the way to the bottom of this document so I can grab out another sheet to work from. There we go. Okay. So let's go ahead down here. Okay, so the first thing that we're going to talk about is a product rule for exponents. If you want to take separate notes, you can, but I don't really think you're going to need to. I think I would almost prefer for you to just kind of watch. Oops, product rule for products. That's not funny. I can't talk and eat at the same time, I guess. For exponents, not that I'm eating, but you know I can't talk and write at the same time. Okay, so that's the first thing we're going to talk about. Excuse me. So you know that if we have 3 to the 5th power, that simply means 3 times 3 times 3 times 3 times 3. If you have 3 to the 2nd power times 3 to the 3rd power, for example, that simply means 3 times 3, that takes care of this bunch, times the second bunch, which would be 3 times 3 times 3, which is the same thing. That's 3 to the 5th power. Or you could have it written this way, 3 times 3 to the 4th power. Well, whoops, that doesn't look like an exponent there. Let's put that up a little bit higher, 3 to the 4th power. Well, what does that mean? Well, that means 3 times this next bunch, which would be 3 times 3 times 3 times 3. Well, how many 3's is that? That's 3 to the 5th power. Okay, so there's a variation of ways that we could write that. So we need to look at this 3 that's right over here that I'm going to highlight for you. We need to look at this 3 right here as though it has an exponent of 1. We know that when there's no exponent, it's assumed to be an exponent of 1, and we're going to cover that a little bit later in the lesson again as well. So let's look at a few of these examples, and you can just kind of talk these through with me over there on your end. But if I had x to the 5th power, and keep in mind that the only, what I want you to, before we actually go into these, go back here for a minute to these ones where we have 3 raised to a power. I want you to notice what happens when we got that exponent of 5. Let's look back at the exponents that we had to begin with. We had a 1 and a 4. Well, we can add those exponents to get this exponent of 5 over here. Same is true here. When I had an exponent of 2 and an exponent of 3, we added those to get that exponent of 5 over there. Okay, so keep in mind that that is actually the rule, the product rule for exponents is this. Let me erase this because I want to actually write this right here. So the product rule for exponents says this. You can have any base, let's just say the base is x, and the exponent is m, and when I multiply that with another number that has the same exact base, and it's raised to a different power, what that means is I take the base and I can add together my exponents. So in other words, when we put these ones that we did up top here, when I have 3 to the 2nd power, times 3 to the 3rd power, look what happened there. It's the base, and then you added your exponents to get 3 to the 5th power. The only time that you can add those exponents, however, is when the bases are the same. So in this case, 3 was our base number. Okay, but this is the actual product rule and how it is actually written. Okay, and that is only when this m and this n are real numbers, and x can never be 0. Okay, So keep that in mind. We talked about, you've been tested on what real numbers are. They're all the numbers that we use, but our base cannot be a 0. All right, so let's move on to some example problems here. I have 4 that we're going to do. You can do these just kind of verbally. If you have x, whoops, that should be an x. If you have x to the 5th times x to the 7th times x to the 2nd power, what would the answer to that be? Well, we notice, first of all, our bases are the same, so we can use the product rule for exponents. So we can just add all of our exponents here, and we would have x to the, let's see, 5 plus 7 is 12, and 2 is 14. So in your head, hopefully that's the answer that you got for that one. Letter B, let's give this one a shot. So we have 5 to the 2nd power times 5 to the 3rd power times 5 to the 2nd power equals 5 to the what power? We have the same bases, so we add our exponents, and it should be 5 to the 7th power. The next one, be letter C, is p to the 5th power. You're going to notice that all the bases are going to have a p. And what would our answer here be? P to the 17th is hopefully what you said. And then the last one, we're going to actually use a number and not a variable. So we have 4 to the 2nd power times 4 to the 3rd power times 4 to the 25th power. What would your answer there be? You should have said 4 to the 30th power. Okay, so that takes care of that particular concept. Let's put another sheet of paper here. And let me scroll down. All right, so the next concept I want us to look at, hold on 1 minute. Let me just go back. I need to familiarize myself here for just a moment with Miss Mish's packet. All right, so if you will notice, watch your eyes as I'm going to scroll really fast. If you look at Miss Mish's packet here, what we just covered was that rule right there. Okay, that's the product rule for exponents. This one's not going to be, we're not going to see this one just yet, but you'll notice, and we did this also in pre-algebra, where if you divide using exponents, instead of adding the exponents, you would subtract the exponents. This one here, if you have a number in parentheses with an exponent, then these two here would get multiplied. You're not going to see any like this today, but Miss Misha has these written out here. And then, of course, a to the negative m power, we know we can't have a negative exponent, so it ends up in the denominator. We just put it down there with a 1 on top, and we change the exponent to a positive number. We're going to talk about this one in just a moment, but we know that any number that's raised to the first power is just the number itself. And in this case, any number that's raised to the power of 0 always turns out to be 1. All right, so I'm going to scroll down to the bottom again, so watch your eyeballs. Get down to this blank sheet. All right, I'm going to try to move quickly here. So this is 21.1 in your book. It's on page, let me look here, page 92. If you want to be there with me, you can be. But you're going to be given a problem that looks like this, and you're going to be asked to simplify it. You'll have x squared times y squared times x to the 5th power times y to the 3rd power. Okay, so it's recommended that we rearrange these in a specific order where we can get the variables beside each other. So I'm going to put x squared times x to the 5th power times y to the 2nd power times y to the 3rd power. Okay, then we can add our exponents on those variables that have the same base. So we notice that we have 2 x's here. And so those are the same base. Let's see if I can change my color. I can. Grab green. And we have our y's that have the same base here. So those two can be put together, and these two can be put together. So our final answer then would be x to the, remember, these are being multiplied, so we add our exponents. And these two are being multiplied, so we add our exponents. Well, what is the last exponent there? Did I erase it? I think I did. Should be a 3. So we have y to the 5th. So the answer to that problem would be x to the 7th power times y to the 5th power. Let's look at 21.2. We're going to simplify this problem here. So we have x squared times y to the 3rd times m to the fifth times x to the third times y to the second. Okay, so we're going to rearrange to put them in a better order. So we would have x squared. Let's put together what we have. So we have our x's. I notice that there are a couple of different y's. We can put those together. And there's one m here. And we'll put that right over here, m to the fifth. We can highlight that, maybe in orange. All right, so there's our three groups of variables, and we've rearranged them so they're next to each other so we can do our addition. Our eyes don't get mixed up on what we're adding together. So we have x's here. We add our exponents for x to the fifth, y to the fifth, and m to the fifth. That is the answer to that particular problem. Okay, now let's take a moment to define. This is the second part of kind of like letter B of the first concept that we're talking about. So if you have x to the first power, we mentioned this a moment ago, we want to define the notation of x to the first power. Anytime you have anything raised to the first power, it's always equal to itself. For example, if I have 5 to the first power, that is simply 5. If I have 7 to the first power, that is simply 7. So x to the first power is simply x. Okay, so let's look at a problem that deals with that. 21.3, we're going to simplify this problem. Simplify x, y to the second, x to the third. All right, now, so we look at any of those that have a notation of x with no exponent. We know it needs to have an exponent of 1. So there's x to the first power, y to the first power, y to the second power, x to the third power. We're going to rearrange. That is step 2. I highly recommend that, Braylon, because you're going to have your bases next to each other. So when you're adding your exponents together, you don't get mixed up on what goes to what. Sometimes your eyes play tricks on us. So let me go ahead and highlight these, and we have our y's here. So let's put our y's together. So x to the first power times x to the third power times y to the first power times y to the second power. Now we can add those. So our x's are x to the fourth power, and our y's are y to the third power. And that is our answer to that particular problem that is simplified. Okay, now let's look at another one. This is 21.4. We're moving right along. We're going to simplify this problem. M to the third power times p times m times x times m to the second power times x to the third power times p to the fifth power. First thing we want to do is try to categorize them or reorganize them or arrange them so that they're in order. So I would write m to the third, m to the first, m to the second. That's all my m's. I would have p to the first, p to the fifth. I would take my x to the first power and my x to the third power. And I usually recount. Did I catch them all? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I have collected all of them. Now I can put them together. So any of my numbers or variables that have a base of m, I'm going to add those exponents together. That comes to 6. I'm going to add my p's together to the 6th, and I'll add my x's together to the 4th power. And that's the answer to that problem. Let me just also point out to you, since these are actually factors, you can write them in any order. There's no real order, especially when you're talking about variables. I guess a lot of times it's recommended, and I even think I read this in this particular lesson, that some people will put them in alphabetical order, and there's a time that that's very appropriate for us to do. But you could, if you decided that you didn't want to write them in that order for whatever reason, and you ended up with p to the 6th, x to the 4th, and m to the 6th, that is completely fine, because we know that you can multiply your factors in any order. So just keep that in mind. All right, the next thing I want to take a look at with you is the addition of like terms with exponents. So it's the same idea with multiplication. When we were multiplying with exponents, now we're going to look at the addition of like terms. They're very different concepts. So it's important that you understand that they're handled differently. So let's look at an example. The first example, if I had 3x squared plus 2x squared. What does that equal? Okay, there's a couple things I can think about here. If this said 3x plus 2x, I feel pretty confident that you would say that's 5x, and you're absolutely right. Okay, so this is not 5x to the fourth. I know we just did a whole bunch of problems where we added exponents, but that is not correct on this one. This one is we take it, excuse me, we look at what kind of terms we have. These are called x squared terms. They have the same, so this 3 and this 2 have the same, I like to refer to it sometimes as the same last name. They have the same one. So we just keep the last name, but we add together our coefficients. So the correct answer to that would be 5x squared. So let's look at another example. If I had x squared times y times p to the fifth, and it was written this way, I also want to make sure we understand this, p to the fifth, because I just talked about this a moment ago. If you had a term like that, this was a 3 and this was a 2, and you were adding these together, these are actually the same terms. How do I know that? Well, let's highlight the ones that are the same. X squared. Whoops, let me grab another color. I have 2 y's. And I have, let's take orange, 2p to the fifth power. So those terms are actually what we would call like terms. So I would add these together, and I could list these in any order. Okay, but that would be the answer to that. I think we had a problem like this last week. We kind of talked about something like this. It just wasn't quite as, they're going to get a little bit more complicated now as we move along. So let's look at, I'm going to move down here. Let's look at 21.5. There's an example that's given here. We're going to simplify this. It is x squared y. Actually, I'm going to write it smaller because it's a little bit long. I'm going to start over here. So we have x squared y p to the fifth plus 2x y squared p to the fifth plus 3p to the fifth x squared y minus 7y squared x p to the fifth. All right, so we have to determine where there are like terms. So I'm going to kind of highlight here some of the things that I see. So I see an x squared, and that's it. I see a y, and I see p to the fifth. Okay, and I see p to the fifth in the other ones, but I don't see an x squared, so I'm just looking to highlight right now those that are like terms. Coefficient here would be a 1. So this one goes with this one. So I'm going to go ahead and write those down here. I'm going to write 1x squared. Actually, I think we can probably go ahead and do the calculation in this. We would have 1 plus 3, so I would have 4x squared y p to the fifth power. And let's see if the next ones are actually matching terms. Let's see if I can grab another color here. So I see an x and an x. I see a y squared and a y squared. And I see a p to the fifth. So it looks like now we have these have the same term. So these are called like terms. So we can add together that second bunch. So I have a positive 2 minus 7. That would give me a minus 5. And I write their last name, x y squared p to the fifth power. Okay, and that would be the answer to that problem. So you're just trying to find who has the last name, but be careful because with all those exponents, it can get a little bit juicy in there. So you want to make sure you're keeping track of what you're writing, what your eyes are seeing. Okay, the next one is equally as long, but it is 2m to the third power times x times y to the second power times p. That's one term, that's a biggie. Plus 3p x y squared m to the third power minus 10 x y to the second power m to the third power p plus yx squared m to the third power p. All right, so we have to figure out who has the same last names. Okay, so now I'm not going to highlight all individual ones because that gets a little bit tough on the eyes too when you have so much going on. So let's just see if we can figure out what goes together. So I see m to the third here, m to the third, m to the third. Oh, they all have m to the third. So who has just an x? Let's see. X, X, X. And okay, this one over here on the far right, you notice has x squared. So that one's not going to match up with any of these other three, so I'm going to erase those. All right. A lot of times too, Braylon, you can do this in your head, so I realize that, but I'm just kind of walking through this with you right now. So I have a y squared, y squared, y squared. So far, so good. Looks like we're going to have a match here. P, P, P. All right, so what it looks like to me then is that all three of these have this, oops, undo, have the same last name, these three right here. All right, so let's put those together. So I have a coefficient of 2 plus a coefficient of 3 minus coefficient of 10. So 2 plus 3 is 5. 5 minus 10 is a negative 5. And then I rewrite their last name, m to the third, doesn't matter what order you pick. I just grab this first one right here. All right, so that took care of this one, and this one. So what is left is this one right over here, plus y, x squared, m to the third power, p. And that would be the answer to that long doozy that we just did. And then this is going to be the last example I do for you that you're watching. So 21.7 is 2x squared times y plus 3yx squared plus x squared y squared minus x squared y minus 4x squared y squared. Okay, let's find like terms. So I see x squared y. Do I see anywhere else that has x squared y? X squared y, and that's that. Let's see here. We have yx squared, and it looks like that's it. Now let's do one in green. I have x squared y squared and x squared y squared. All right, so there's what we have to put together. So I'm going to underline these that I highlighted in yellow just one time. We're going to write those down here. We're going to figure them out. So my coefficient is a 2 here and a 1 here. So 2, we see a subtraction sign there. So 2 minus 1 is 1 x squared y, or we can just call it x squared y. Hang on a second here. It looks like I wrote, did I write everything down? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I did. I want to make sure I wrote down these exponents correctly because it looks like I did something different on my work here. Oh, hopefully you're thinking about correcting me over there, Braylon. So take a look here. I missed it. So I have an x squared y, just like I did on the other two that I highlighted in yellow. So I need to go back and underline that. I hope you were screaming, Mrs. Quigley, Mrs. Quigley. Okay, so let's look at our coefficients again. 2 plus 3 is 5. 5 minus 1 is 4. So we have 4x squared y. And then let's put together what we have in the green highlights. So here I have a 1, and over here I have a 4, but it's being subtracted. So 1 minus 4 would be minus 3x squared y squared. Okay, I know you like to talk through your problems, and that's okay to a point, but you're getting a lot of exponents and a lot of variables involved here, and they tend to look the same. So please be careful when you're doing that. I would try to find a system that works for you where you can either, I use a highlighter here because it's easy for me, but you can just use your pencil and you can, like, you know, underline these guys are the same, and then say, oh, these guys are the same, and highlight, you know, maybe not highlight, but underline those a few times so you can keep them together. That's just a recommendation for you. All right, now I'm going to scroll way up to the top, so watch your eyes. Here we go. Okay, so let's look here at the examples to the right over here where we see we're going to simplify. You're going to do those on your own if you want to pause the video and do those, and then I'm going to put the answers here now. But go ahead and pause the video, come back and see if you got this correct, and I'll see you in just a moment. Okay, so this one we know that m to the first power is simply m. That's what our rule says over here. And m to the 0 is always 1. Okay, here we have k to the 5th power times k to the 2nd power. We know that those are being multiplied, so we just add our exponents, so it would be k to the 7th power. On the next one, we try to put our bases together, so we have an x to the 6th power and an x to the 2nd power, and then we have a base over here that has a y, so those two are going to be put together, and so we just add our exponents, so we would have x to the 8th power and y to the 6th power. And then on the last one over here, number 4, we're going to look for some that we can match up. So I have m squared over here, and I have m to the 1st power here. So we already know this is not going to be a match. So actually, this is the answer to number 4. All right, now the next part that you're going to do, Braylon, and you can do these on your own. So once I give you the instructions here, what page to find these on, you can do these, and Mom can check these for you. And if you have questions, you can simply hold those for me. You can give me a call or text or whatever, and we can work them out together when we can get together. But these are coming from page 93 in your book. And you'll see down there, you're simplifying. There's A, B, C, and D. So like the first one is x, y, x to the 4th. These are all being multiplied times x to the 3rd times y to the 5th. Okay, so those are those problems down there. You see those at the bottom of page 93, just before the problem set. So go ahead and work those out as practice problems. I'm going to keep the video going to work through those. If you do want to come back on and check them with me, that is fine. Or you can just have your mom pull out the answer key and check those for you to see that you got those right. When you're finished with those practice problems, you're going to do the lesson problems for lesson 21. There is one honors question there. You should go ahead and do that so you can get an honors credit for this. So far, when I'm looking at the honors questions that are listed here, we've already done them in pre-algebra. So it's a review problem. So you should be able to do that one. So go ahead and attempt that. And I'm going to go ahead and finish up these practice problems. But again, you can pop back on and see how I did them, or you can have Mom grade them and see how you did. Okay, so stay tuned for lesson 21. That'll be on another video coming soon. All right, Braylon, talk to you later. Bye-bye. Okay, so I'm going to go ahead and do practice problem A. So we need to rearrange these. We have x to the 1st power times x to the 4th times x to the 3rd times y to the 1st power times y to the 5th power. And we can put these together. So we have x to the 8th power times y to the 6th power, and that is the answer to the first problem. Yes, I'm talking very fast. Okay, letter B, we have x to the 3rd times x times y to the 2nd times y to the 5th times x to the 7th. I'm going to rearrange those so the x's are grouped together. So I have x to the 3rd times x to the 1st times x to the 7th times x to the 2nd times, times y to the 2nd times y to the 5th. We'll put our x's together. So we have x to the 4, 7, 11th power. And we have, I think I forgot something here. There's also 2 m's here as I'm glancing at my sheet. So we also need to put those m to the 1st times m to the 1st. So we have x to the 11th times y to the 7th times m to the 2nd power. And that's your answer for B. Letter C is 2. Now we're going to be using the rule where we're adding like terms. X squared y to the 3rd plus xy minus 8y to the 3rd x squared. I have to write small minus 5yx. All right, here we go. So let's find our like terms. So I have x squared y to the 3rd. Do I have that anywhere else? X squared y to the 3rd is right there. It's just reversed. So let's check these out. Do the next ones go together? We have an xy and we have a yx, and those are exactly the same. They're just flipped around, and we know that as factors, they can be flipped around, but they will go together. So let's take together what's in yellow and put those together. So I have 2 minus 8, which is a negative 6, x squared y to the 3rd power. And then I have what's in green, which there's a coefficient of 1 here. So I have 1 minus 5, which is a negative 4. So we write that as minus 4 xy. And that is the answer to that problem. Okay, and then letter D is x to the 6th power times y plus y x to the 6th power plus 3xy minus 5xy to the 6th. So again, we try to find out who matches. So I have x to the 6th y right here. Here I have y x to the 6th. So that is the same. I have x y to the 6th over here as well. And then this guy here is just going to be all by himself. So let's put together what's in green. So I have a coefficient of 1, a coefficient of 1, and a coefficient of 5 that's being subtracted here. So we have 1 plus 1 is 2. 2 minus 5 is negative 3, but I did something wrong here. What did I do? 2x to the 6th. Did I write something incorrectly? Because I've already figured out my answer on this one and it's not going to jive. So let me see what I did. Oh, goodness gracious. Okay, hopefully, once again, if you were checking with me, Braylon, you caught that. This is xy to the 6th. It's not yx to the 6th. So do you see how it can get a little complicated? So that's going to be a term all to itself over here. So I'm going to highlight it in pink so I don't get it mixed up. All right, so let's put these two together here. So I have 2x to the 6th power times y. I have plus 3xy minus 5xy to the 6th power. And that's the answer to that problem. I hope that makes sense. Okay, so watch those exponents. Watch who they're assigned to. When you're trying to match them up, just be careful. You can see how it can get a little bit messy at times. So I recommend trying to sort them out, maybe underline them once, and then the next pair underline it twice. Just develop a system that works for you. Okay, that's it for lesson 21. We'll talk to you soon.